Hello and welcome to Boost Chemistry Revision. This video is an introduction to A-level organic chemistry. We'll cover the main homologous series, their functional groups, and different types of chemical formulae. If this is your first time here, we offer tutorials and revision tips on A-level chemistry, hosted by qualified and experienced chemistry teachers. We'd love for you to connect with us on social media at Boost Revision, links below, and also visit our website for more information, including free downloads. Let's start with some of what you learned at GCSE. You should be able to write the general, molecular, and displayed formulae for the following homologous series: alkanes and alkenes if you are on double science, and alcohols, carboxylic acids, and esters if you are on triple science. You should also be able to name the straight chain organic compounds with up to 4 carbons for these homologous series, and you should also be able to identify the functional group for these homologous series. Then, moving from GCSE to A-level or IB, you'd be expected to identify a few more homologous series and functional groups. That's aldehydes, ketones, and halogenoalkanes. You'll also learn how to write the structural and skeletal formula for different types of organic compounds, and use IUPAC nomenclature, which are the international naming rules, to name straight chain and branched organic compounds with up to 10 carbons in the primary chain. Just in case you don't already know, a homologous series is a group or family of compounds that have the same functional group and the same general formula. Members of the series differ by CH2. So for example, the first 4 alkanes are CH4, C2H6, C3H8 and C4H10, each differing by CH2. So these are the main homologous series, which we've already mentioned. As I said, you'd be expected to draw the general formula for each of these homologous series and identify their functional groups. You'll notice that the general formula is an algebraic formula for a homologous series, using N to denote the number of carbons in the chain. The general formula will tell us how many hydrogens there are to every carbon in each homologous series. Note that in alcohols and carboxylic acids, the general formula is sometimes written with the functional group at the end to make it clear which homologous series we're talking about, because some of the homologous series have similar general formulae. You probably remember that alkanes have all carbon-to-carbon single bonds, and we call these saturated hydrocarbons. Hydrocarbons meaning they contain only hydrogen and carbon. Alkenes are also hydrocarbons, but they contain at least one carbon-to-carbon double bond. We call these unsaturated. The functional group for alcohols is OH, and note that I've drawn an R here in the displayed formula. This is commonly used in more advanced chemistry as a placeholder for a carbon-based chain. This means that an alcohol could have any carbon-based chain and then COH. Carboxylic acids too will have any kind of carbon-based chain, and they'll always have the C double bond O, OH at the end. Esters are made from alcohols and carboxylic acids reacted together. So we normally write them with 2 different R groups on either side to show that the R group on the left may be different to the R group on the right. Note that the second R group has a little 1 down the bottom of it to show that it's a different R group from the first one. Aldehydes are a new functional group that you won't have come across. It's quite similar to carboxylic acids, but instead of having C double bond O, OH, it has C double bond O and just an H without the O next to it. These are formed from the oxidation of primary alcohols, which you'll learn about later in the course. Ketones again contain a carbon attached to an oxygen by a double bond, and that double bond O always exists in the middle of a carbon chain. So again, we write the ketones with 2 separate R groups to show that we can have 2 different carbon chains on either side of the C double bond O. Finally, halogenoalkanes are alkanes with a halogen attached, where the halogen has replaced one of the hydrogens. So these can be written as R for the carbon chain attached to any of the halogens: fluorine, chlorine, bromine, or iodine. And as you can see from the general formula, they're usually generalized with an X to denote the halogen. So now we've identified the homologous series and functional groups. Let's go on to look at the different types of formula. You'll already have come across many of these at GCSE, but you may not have come across the structural formula, which gives the minimum detail needed to show the arrangement of atoms in a molecule. This is easiest to see when you compare it directly to displayed formula, and you'll see this in a slide in a second. You're also unlikely to have come across the skeletal formula, which shows the carbon skeleton and the functional groups, but doesn't show the hydrogen atoms. This is the most simplified type of formula you can get, and you'll see it used more and more throughout the course as you start to deal with more and more complex organic molecules. So let's have a look at the different types of formula for butane. As you know, the molecular formula gives the number of each type of atom in a molecule. So for butane, we have 4 carbons and 10 hydrogens. The empirical formula is the simplest whole number ratio of atoms in a molecule. So to write the empirical formula, we simplify C4H10 into the smallest common denominator. So we divide both by 2 and we get C2H5. Here is the displayed formula for butane, showing 4 carbons, all with single bonds between them, and hydrogens attached all the way around. When you're drawing displayed formula, make sure to double check that each carbon has a total of 4 bonds and each hydrogen has a total of 1 bond. It seems pretty straightforward here when we're drawing an alkane, but it can get more complex later on. So it's always a useful check to do. Now let's look at the structural formula. We said it was the minimum detail needed to show the arrangement of atoms in a molecule. So we've got CH3, CH2, CH2, CH3 at the end. You can do a final check by counting 4 carbons and 10 hydrogens. Perfect. Lastly, the skeletal formula. As we said, we draw the carbon skeleton and the functional group, but none of the hydrogen atoms. Each line represents a bond between 2 carbon atoms. So this butane skeleton has 4 carbon atoms, 2 at each end and 2 at each of the bends between the lines. If there are no other functional groups attached to the skeleton, then it's safe to assume that we've got the maximum number of hydrogens attached to each carbon. And to give you a bit more practice with the idea of skeletal formula, I've drawn the skeletal formula for the member of each homologous series that contains a total of 4 carbons. That brings us to the end of this introduction to organic chemistry, recapping some of what you learnt at GCSE and introducing you to A-level chemistry. In the next video, we'll be looking at naming organic compounds. If you liked this one, please give it a thumbs up and consider subscribing to be notified when the next one is released. Thanks very much for watching.